This project deals with two equations commonly used in fluid mechanics, Bernoulli and energy equations. The Bernoulli equation is concerned with the conservation of potential, kinetic and flow energies of a fluid stream and their conversion to each other in regions of law. This is the state where net viscous forces are negligible and other restrictive conditions apply. The energy equation is a statement of the conservation of energy principle. In this project, we derive the Bernoulli equation by applying Newton's second law to a fluid element along a streamline and demonstrate its use using a flexible drinking straw and a roller.
For literature review, Banerjee et al. Have measured mass velocity in transient steam water flow with pitted tubes which were not directly calibrated. Pitted tube also be used by Anderson and Manzouranis, Adorni et al., Gillette et al., Delhave, Zarkoway, and Dick to investigate steady gas-liquid flow. Pitted tube also be used by Dusson and Shapiro at 1955, Dalman and Lowe at 1957 for gas-solid flow. The main objective was to determine whether it was feasible to use pitted tubes to measure mass velocity in high pressure, high mass velocity steam water flows.
For methodology, first assume that energy is conserved and not lost due to friction. Bend the straw at a 45-degree angle and submerge a portion of the straw parallel with the current into the water. The other portion of the straw should be exposed in the air and at a 45-degree angle. Water will travel up the straw until some point, and the maximum height that the water level reaches can be measured with a ruler. If the water flow velocity in the river is v, then due to the geometry, the water flow velocity traveling up the straw will be as follows: v cosine 45 equal v square.
So for result and discussion, this is our proposal design of the project, which is we use straw and a ruler, and the equation that we use to calculate our result in this project, which is Bernoulli equation, which is density 1 over density gravity plus v square over 2 gravity plus z1 equals to p2 over p gravity plus v square over 2g plus z2, and the z1 and z2 will be 0 in this project. The second method that we can use is we use conservation of energy, which is conservation of potential energy PE plus kinetic energy KE, and the final equation that we get to use to calculate the velocity is V equals to square root 2 gravity height.
Conclusion: this project highlights the importance of choosing an appropriate method to obtain discharge measurement in rivers, streams, or other natural watercourses. The most important factor to obtain is an accurate rating curve that is able to translate river stage value continuously measured in river station into discharge for every flow condition. Confidence in the rating curve is vital, as it is used to obtain discharge value for designing building, so it is essential that the measured data are reliable and have a low uncertainty.